Okay, we are recording. It is 20 after on the 21st of April. And like we typically do, since we may have a couple of people, I think Corey's here from lab, and let's see the other two lab folks. But anyway, let's open up the floor for questions related to lab. I guess I should mention that for this week, we're looking at exercises 31 through 33. And I hope you've all had a chance to look at the schedule. So those exercises have been posted in the lab course shell, and like 26, 27, and 28, what I basically did was looked as best I could for comparable videos related to the Kirby-Bauer method of evaluating antiseptics and disinfectants in plates. And then there is effectiveness of hand washing exercise too. So there's several videos, as I recall, in those three exercises in three folders in the lab course shell. So my recommendation, as was the case last week, is to look over those in your lab book so that you're somewhat familiar with what we would have done had we met, and then watch the videos, and that's about all we can do.
I have a question.
Okay.
Other exercise 26 and 30, like in the quiz you said you posted videos and stuff about the exercises, but I didn't see any videos. I don't know if you took them down, or because I did not see any videos in exercise 26 and 30, but they were on the quiz.
Right. They weren't available during the quiz, but they were available up to the quiz.
No,
You should
but like I didn't see like videos of the exercise before the quiz. And even after the quiz, I went back and checked. I was like, maybe I just didn't see, but there were no exercises.
Well, let's take a look.
PI.
Do you see the Blackboard coming
Yes.
up? So let's see, 20 pH. So there's one video. You didn't see that?
No.
There's 1, 2, 3, 4 videos. So I don't know. Are other people able to access the videos in those exercises? I don't know, Vera. They're there. They weren't there when you took the quiz, but they were there up to that point in time. So you need to be looking at these before the quiz, not during. So go back, take a look. Let me know if you're still having problems, but you shouldn't have any trouble getting in. Okay. And so as I mentioned earlier, those exercises that you're doing this week, 31, 32, 33, again, there's videos there. So maybe while we're doing this, Vera, can you go and open up another page and make sure you can get in?
Sure. I have a Blackboard on my phone.
Okay. Yeah, either way. Okay. Other questions related to lab stuff? Corey? Any questions? All right. All right, well then let's spend the rest of the time talking about lectures material. If you have any questions related to that, we can certainly talk about that. We're scheduled to look at chapter 13 this week. Now, remember, we've got the exam scheduled for Friday 4 to 6. And then we'll still plan to meet on Thursday. People want to meet, I'll be here. And we can talk about 13 as well. So it's not like you just have one lecture on 13 or one time to meet. We have today and Thursday. And I was looking over this PowerPoint this morning, and boy, if there's a chapter in our book that is appropriate that we talk about amid the COVID-19 situation, it's this chapter. It talks about epidemiology as one aspect of this chapter, one part of it. And then the other components kind of talk about infection and disease. So it's just, I think it's one of the more interesting chapters of them all, actually. I hope you find that to be the case as well. So we can also talk about any of the preceding chapters as well. So you tell me kind of where you are, what you'd like to review.
Maybe a little bit of review.
Say that again, please.
Like review for the test, for the exam.
Okay, well, what do you want to review? I mean, that's a lot of material.
Yeah.
What is causing you angst, I guess is what I'd ask.
Can you go back over like conjugation and like review like transformation and like transduction?
Absolutely. So that was in
Chapter 9.
9. Thank you.
Like a
Okay.
brief review.
All right. So let's go to share screen. Chapter 9. Do you guys see that on your screens?
Yes.
Okay, excellent. I think that's toward the end, isn't it? Yeah. Okay, so this relates to ways in which bacteria can acquire new genes. That's in essence what these three processes talk about. And the first one involves a physical contact between a donor and a recipient, basically, via what's referred to as the sex pilus. I'm pretty sure that's a long I, pilus. And so here we've got an F plus cell, a little superscript plus there, indicating that this is a donor. And in this particular instance, this F plus bacterial cell is going to transfer a replicated copy of a plasmid. Now you can think of the F factor plasmid as the instruction booklet to be able to make a sex pilus. So think of F. F actually stands for fertility, but in a very bizarre, weird kind of way, because this has nothing to do with sperm and egg. So I don't know where fertility comes from, but that's what you'll often refer or hear referred to as the F letter. I'm not sure if your book does that or not, but anyway. And so here's that sex pilus that the F plus cell has constructed toward its sister cell. We'll say another species of E. coli. I'm just making that up, pretends 2 E. coli cells. And of course, the transfer then occurs. Once the pilus replicates in the one cell, it's just basically brought across into the other cell. And then the F minus becomes a what? If it gets the F factor plasmid, it can do what?
It becomes an F plus cell.
Right, it can construct the sex pilus. Now, again, the purpose of the pilus is for what? Strictly, what does it do?
Can connect to another cell so they can distribute the genes to another one.
Exactly, it's a bridge constructed so that traffic in the form of genes can cross the bridge to another cell, basically. Okay, so there's the replication and the transfer. Now, you can also conjugate R factor plasmids between cells. What do you think that means?
It's the resistance factor. It allows them to be like resistant to different antibiotics.
Exactly. R factor plasmids provide resistance against some drug, some chemical in the environment. And that's an important way in which drug resistance can be passed on from one cell to another via a sex pilus. Yeah. And there's a video, you can watch that, but it basically talks about what we just talked about. So you can watch that. We did not get into high frequency recombination, so that's not something you need to worry about. The book does spend just a little bit of time talking about that, but we're not going to worry about HFR transfer. So that's conjugation. Olivia, questions on that? That makes sense?
Yeah, I'm all good with that now.
Okay, anybody else? Okay. The second process, transformation, was first studied, not that this guy knew anything of, what was going on at that time actually, but back in the 1920s with strep pneumoniae and mice. And basically what Frederick Griffith did, this British medical officer in his laboratory in London, was he was culturing two different types of strep. One was called S and one was called R. Does anybody remember what the S kind of represents?
The smooth.
Smooth, right? If you look at the colony, they apparently, microscopically, the colonies had a smooth appearance to them. And really, S, smooth, infers the presence of an outer capsule to the strep pneumoniae bacterium. Okay, so they're encapsulated bacteria. The S strain is encapsulated. And having a capsule can be beneficial to a bacterium because it increases its virulence, its pathogenicity. So as this box obviously indicates, when he injected S strain strep into mice, it killed the mice. The mouse's defense system could not, immune system could not control the S strain strep, and it killed the mice. And then here's this other strain he cultured called R strain strep. R for rough. Again, the colonies look from a stereo microscope, dissecting scope point of view, morphologically different. Obviously, you can kind of see that on the sketch. And that was because when he examined these after having done a capsule stain, he didn't see a capsule. He did find capsules on the S strain, right? And of course, when you inject this into mice, the non-encapsulated, non-pathogenic form was easily handled by the immune system of the mouse. The mouse fine, doesn't die. So that's sort of his preliminary discovery with respect to pathogenicity of Streptococcus pneumoniae. The R strain, not bad. S strain, bad. Then he takes some S strain strep, the pathogenic form, of the strep, and he heat kills the cells. He subjects them to heat, lets the broth cool down, pulls some up into a syringe, injects it into the mice. Obviously, mice are fine. And then, of course, the last part of his experiment involved taking heat-killed S and adding living R, pulling some of that mixture into a syringe, injecting that into a whole bunch of test animals, and all the mice die. And when he did a necropsy on these mice and examined the tissues, what did he find in terms of bacteria? Anybody but Maggie, because she knows. Come on, you guys should know this. If you don't know this, you have not been studying. This is not rocket science. If the mice dies, it's pretty safe to assume that what kind of bacteria are in the mice?
S strain.
Right. Where'd they come from? They're dead.
Transformation of the R strain to S strain.
Okay, explain it.
The DNA from the R strain was, or the DNA from the S strain was sent into the R strain, and it transformed the R strain back into the virulent S strain.
So through a sex pilus?
Transformation? No.
No.
It was just like picked up by the membranes.
Yeah, we call it free DNA.
Yeah.
Yeah, so Bella's exactly right. Those heat-killed S strain cells were dead, obviously, and some of the DNA that was in the plasmid and or the nucleoid was then released into the surroundings, and little pieces of that DNA, including the gene, right, that allowed, or that was the instruction booklet. Okay, here's the gene. What does it allow me to do if I'm now R strain? I got the book, what can I do? This is the free DNA that I, as an R strain strep, absorbed. What am I going to do with this instruction booklet? With that, it's going to allow me to do what?
To copy the information.
To construct a capsule, right? The formation of the capsule, the instruction booklet to do that came from the S strain strep. So, you know, you got to kind of think of it, make up metaphors, stories, weird, dumb analogies like, yeah, I'm the R strain strep. I have acquired free DNA. Here it is. I just absorb it, as Bella said. And that free DNA has the information that I can read and learn about so that I can construct around me a capsule. And I therefore become S strain, right? So that's the process. So that's the second way in which bacteria can acquire genes. They can acquire this free floating DNA that's out in the environment, whose source is likely another bacterium that died. And that particular bit of information can be helpful to bacteria, as is the case here with the R strain becoming S. Okay, good with that? So I think it's aptly named transformation. The cell has been transformed, in this case from R to S. And the third mechanism, which is probably a little more technical, involves the use of bacteriophages as mediators, as carriers of the bacterial genes from some bacteria to other bacteria. So you have to fundamentally understand the life cycle of bacteriophages, which you should know because we studied this back in the virus chapter, whatever chapter that was, I forget. Chapter 7, 4, I forget. So if you don't remember bacteriophages or what they do, you got to go back and just spend 5 minutes reviewing the figure that talks about bacteriophage biology. Then you can come back here, and this is going to make a lot more sense. Now note here that this process involves the transfer of genes from one species of bacteria to the same species of bacteria. Transformation could involve transfer of DNA from different species of bacteria, Staph to E. coli, E. coli to Bacillus, Bacillus to Enterobacter, or whatever. So this is usually E. coli to E. coli, Bacillus to Bacillus, Klebsiella to Klebsiella, whatever it might be. Actually, I should be more specific because I gave you genera there, didn't I? Klebsiella, Bacillus, those are genera. We're talking about here having to be the same species, right? So that's even more specific. So we discussed two different types, a generalized and a specialized form of transduction, both basically working in the same way. There's some differences there, but in essence, let's talk about generalized, where we've got bacteriophage here in blue, landing on a cell, injecting, of course, its DNA into the cell. So we're showing the phage DNA in red, the bacterial in blue, obviously. What is the cell going to do in response to that injection of the phage DNA?
It's going to start making viral proteins.
It's going to start making more viral proteins and, of course, more viral nucleic acids as well, right? In other words, it's got to act as a factory for more virus particles. We've talked about that a lot. So we are replicating that red DNA, and we're incorporating that into capsids, protein capsids, also created by the host cell. And of course, here are the intact bacteriophages, right? After all that's occurred. Notice that most of these phages look like the invader phage here that started the whole process off, right? But what do we see here? We've got a phage that has in its capsid not phage DNA, but blue DNA, which of course is bacterial. So when we say host DNA, we're talking host cell here, right? Yeah. And so when these viruses erupt from the cell and the cell lyses, out flies a bunch of normal, we'll call them, red nucleic acid phage, and then we have occasional blue nucleic acid phage, which if they go to invade another E. coli cell, injects its nucleic acid in, right? Does this cell really care what the nucleic acid is? No. It just is going to do what to it? Well, in this particular instance, it is incorporating this DNA into the chromosome. Because this could enter this lysogenic phase and just sit here. It doesn't have to necessarily kick into the lytic phase right away, does it? It might, but it doesn't have to. So what has this bacterium acquired? Well, what did the R strain strep acquire in transformation? Same thing, right? A new instruction booklet, a new set of genes. Maybe one gene, maybe a whole host of genes. But it's now part of the genome of the bacterial cell. That bacterial cell has potentially gained an advantage over other cells that maybe didn't get that, because if, again, in that instruction booklet, somehow were the instructions to prevent that cell from dying in the presence of certain chemicals, it's a positive for the cell. In specialized transduction, we're just carrying a particular piece of the host bacterial chromosome, the genome. So it's just a more highly specialized process in terms of what is actually transferred from one bacterial cell to another and how it's incorporated into the bacterial chromosome. So those are the three mechanisms by which genes are transferred from bacterial cell to bacterial cell. Questions, Olivia?
No, I think that just covered a broad range of it. I just wanted to get refreshed on it, basically.
Okay, great. Anybody else? Questions on those processes? Okay, how about other questions related to 9, 10, 11, 12?
I don't have a question about material. I was just wondering if before you start like explaining whatever the next question is, if you could just like maybe stop sharing your screen and then start again. On my computer, it's just frozen on like your
Sure.
like, files page, and I can't see the PowerPoint.
Okay,
Thank you.
I stopped sharing. Sorry about that. I don't know what happened.
That's okay. I just didn't want to interrupt you.
Oh, that's all right. Come on, you guys must have some questions. No?
For chapter 12, do we need to know like the actions of each specific medication?
Let's take a look at that. So when you ask about specific drugs and what they do, are you talking about this diagram for the most part?
I can only see your files page right now.
Oh,
I thought maybe it was my computer because it's happening to me again.
but on the previous
I can also.
PowerPoint, did you see all the slides I was going through, transduction and so forth?
No.
Yes? No?
No.
Also,
No.
so on the previous PowerPoint, you didn't see any of the slides I was going through?
No, I was just using like my own power.
Oh, I wish you would have said something. Okay, I'm not exactly sure why this, I guess I can't go from one screen to another screen. I got to go right directly to the PowerPoint apparently. Yeah, sorry about that. I was just assuming you were seeing what I was going through, you know, so tell me if you're not, geez. All right, so this is 13. Do you see 13 there? Universal blood and body fluid?
Yes.
Yeah, okay.
Yeah.
And that's not the one we want, but all right. 13, here we go. Are we good here?
Yep.
All right, this is actually the PDF. I want to go to the actual PowerPoint. I saved another version of the PDF. I updated 13 today a little bit. I tweaked a couple slides. Where is the non-PDF version of my, let's see, this was chapter 12, right, Maggie?
Yeah.
12, sorry, I'm getting all these mixed up. I got too darn much stuff open. Okay. How about now? What do you see?
I can see 12.
Yeah.
Mechanisms of drug action.
Mm-hmm.
Okay, okay. So your question was, do we need to know the action of the various drugs? And so this was the slide I was looking at when I asked that question. And what the chapter does is it introduces, of course, the 5 major mechanisms of drug action. And then after introducing this slide, it goes into specifics. when I put the PowerPoint together, I tried as best I could, because I know it was a little confusing. I tried to be as logical in my presentation of the drugs and their actions on the cell as I could. So it shouldn't be too tough to go from this slide to the various future slides. So if I asked you a question, let's say on penicillin, yes, you should be familiar with the fact that it prevents peptidoglycan formation in the cell wall.
Okay.
If I talk about chloramphenicol, you should realize that it impacts the ribosome action function and it impedes protein production. And I know that initially it's like, oh my God, it's a lot of drugs. Well, yes and no. This guy here, the phosphomycin, it's listed. We didn't really get into it much in future slides, so that's not something you need to really worry about. Cycloserine, likewise, the book doesn't talk much about that. It lists them here, obviously, but I knew that there was a limit as to what I could give you or what I expected you to know. For cell membrane, effects, there's only one group, so that's easy. There's not that many for DNA, RNA. It's mostly the cell wall inhibitors and some of the ribosome effectors. This one, the book does not talk too much about. This one, likewise. So there's at least 4 or 5 in this group that you're not gonna have to worry about. But I would know aminoglycosides, tetracyclines, we go over that quite a bit. These two, anything that ends in phenol. Oh, I want to do that again here, sorry, go back to here. Or mycin often act in similar ways because they're typically synthetic forms of the naturally occurring antibiotic. Anything that ends in ilin are related to penicillins. So there's a few little tricks you can use to kind of help get those cemented in your head.
For sulfonamides, you have I think there's 3 different sulfonamides. Should we know those specifics or just that sulfonamides are metabolic pathways?
Okay.
Inhibit the metabolic pathway.
All right, let's see. That's the last, yeah, that's down here, right. Yes, I would say you should know sulfonamides and trimethoprim. These other two, sulfoxazole and sulfadiazine, no, don't worry about having to know those two specifically and what they're used for. Now, we did talk, if I remember, on Thursday, quite a bit about this pathway, didn't we?
Yeah.
And so the reason I think it's helpful to know those two is because we talked about them. How the sulfonamides kind of impact the early part of the process while trimethoprim comes in a little bit later. Yeah. Do you need to know all these intermediate molecules? No, no. Should you know what PABA is? Yeah, because that makes you better understand how sulfonamides act as competitive inhibitors with PABA. So I think you should know that PABA is the kind of the precursor substrate, which leads to the eventual formation of, some of these nucleotides and or amino acids, which of course are building blocks for proteins. But folic acid is the key. That cells, all cells, not just bacteria, but your cells too, have to make folic acid so that when cells replicate and divide, your cells, you've got to have that folic acid to generate more nucleotides. Nucleotides, remember, are sugars, phosphate, bases. They're the building blocks of RNA and DNA. So if you can't make folic acid, you can't replicate your DNA. I don't care if you're a prokaryote or eukaryote. This particular example is talking about impeding prokaryotic nucleotide synthesis, right? Although some people can be allergic to sulfa drugs. or even trimethoprim, I'm sure there are allergic reactions some people might have with those. But for the most part, they don't cause major issues for most people because this is acting on prokaryotes. Does that help kind of answer that?
Yeah.
You know, there's this figure 2 that I think does a really nice job kind of laying it all out, at least a lot of them, a lot of these prokaryotic ribosome inhibitors, if you will. And of course, I think the book does a decent job kind of inserting the drugs in different places so that you can visibly see what impact it has on whether it's translocation of the ribosome or the introduction of new tRNA or preventing the large and small subunits from coming together. I mean, there's all sorts of ways that you can affect the ribosome in a negative sort of way. Good for you, bad for the bacterial cell, right? And so, as I think we mentioned on Thursday, with respect to COVID-19 and trying to find out therapies to control it, if you understand the biology of viruses, then you can try to block a number of different important procedures or steps, processes that have to take place from the time the virus gets into the cell to the time it exits. Don't let it in, don't let it out. Don't let the cell replicate the viral DNA. I mean, there's a whole host of things that you could potentially do in trying to curb the action of the virus. So that's what's going on as we speak. Frantically. And with respect to antibody therapy, that directly relates to the next, actually the last chapter we're going to get into in another week or so, 15. You know, the immunity stuff. So this is just so pertinent that we're talking about these topics right now. It's just, couldn't time it any better. Other questions related to 12, 11, probably haven't looked at 13 yet, but I know you're all getting ready for the test, but don't blow off 13 either. You should be getting into that a little bit. I would say that 13, just off the cuff, is much less in technicalities than it is in broad conceptual material. So you should find 13, I think, an easier read than 12 or 9 or 10. Just sneak preview kind of thing. How about questions on these drug actions? Anything you want to ask about here? Again, I tried to make the PowerPoint slides as good as I could. Don't get all caught up in the chemistry. But I mean, you're not going to know how polymyxins work unless you understand cell membrane structure, right? And all this stuff builds.
Can you go to chapter 11 and go through like 1 through 11 and know like what exactly of those we need to know for the germicidal categories? Like, do we need to know if they're like low, intermediate, or like the high? Like
Okay, let's go to 11. I'm going to have to pull that up. Oops. Okay, just give me a second here. I gotta go in and find that. Okay, do you see chapter 11 there?
Mhm.
Okay. Oh, are you talking about the list at the end of the chapter? This one? Yeah.
Yeah, and then like after with a couple PowerPoint slides.
Say that one more time.
Like the PowerPoint slides that like relate with like the halogens, and then like to know like what on that do we need to know, like chlorine and like the hypochlorites and like how that acts on like a cell and stuff like that, and like
Okay.
what level it is. Do you know what I'm trying to say? Like for all of them, like
Okay.
what they're used for and all that stuff.
Okay, gotcha. All right. So I sort of put asterisk next to what, 8 of the 11 or so. I did my quick math, I think. And so those would be the ones that I would know a little more specifics about. And so as it relates to, let's say, well, you mentioned the halogens, which I think was category 1. Yeah, chlorine and iodine. There's only 2 listed, so yes, I think you should know chlorine and iodine. The hypochlorites are just forms of chlorine. So, I mean, I don't care that you know this. I don't care that you necessarily know iodophores. But betadine, a lot of you are familiar, maybe if you worked at the hospital, this is a topical material that they often put on skin before they do a surgery. So it's a well-known antimicrobial. It's been in existence since the Civil War, iodine. And so, yeah, I think you should be familiar with the fact that most of these halogens are impacting proteins, bacterial proteins. So I would try to connect the germicide to exactly how does it impact the bacterial cell. Occasionally, I throw materials on here like how many wastewater treatment plants will use chlorine as part of the treatment process because it's been very effective, obviously, in killing lots of potential pathogenic bacteria. So if you ever took a tour of a wastewater treatment plant, they would talk about chlorine and how they use it and as one of the steps of quaternary or tertiary treatment. This is kind of interesting. Using chlorine-treated water to submerge vegetables in. That's really interesting, I think. And then we go through the list of phenolics and chlorhexidine. So yes, you should have a sense of those 8 or so asterisked germicides. What are they? How are they used? How do they impact microbes? And again, some of you that work in the healthcare industry, maybe you've heard of Hibiclens. It's a very common surfactant that a lot of hospitals use. Anybody know anything about Hibiclens? Have you ever heard of Hibiclens? No? Bella is shaking her head.
Yes.
Okay. A lot of these antimicrobial properties have been known for quite a long time. Obviously, here we're talking about the product Listerine, named after Joseph Lister, and I think did we not talk about this in class? I think we did. Very fascinating historical overview of carbolic acid or phenol, how it was used in the 1800s, right, to lessen post-operative infection rates. Yeah, and we talked about the surgical glove that the doctor made for his nurse and they got married and all that stuff, right? Yeah, it's such a romantic story. It is. How can you not like that? Alcohol, you just finished an exercise in lab about alcohols. Hydrogen peroxide. A lot of you have this in your medicine cabinet, I suspect, some of you. Vera's shaking her head, right? Yeah.
Yeah.
So when you
I haven't eaten last night.
say it again.
I even used some of it last night because
You
my
did?
ears are all itchy. Yeah.
How did you use it?
I just like, I put a drop of it in my ear so I don't have to itch it.
Oh, okay. And it bubbled?
Yeah.
Uh-huh. When you get a cut, sometimes people will pour hydrogen peroxide on a cut, right? And it hurts, it burns, it's not fun. And so the bubbling action is due to the oxygen gas that's given off, okay? So if you look at the chemistry here, what really happens when catalase breaks that down, remember from lab, right? You guys remember all this? Yeah, you should. What are the end products here? H2O2 in the presence of catalase makes what?
Hydrogen and oxygen gas.
It makes oxygen gas, yeah. And what else?
Water.
Water, right. And if you look closely, you can kind of see those two constituents within here, within this molecule, although you need two of them here if you want to balance the equation, but that's chemistry. So what's the purpose of adding hydrogen peroxide to a cut? I mean, why do we do that? Well, we did it because mom did it, and we have it in our medicine cabinet because mom had it in hers. And we added it because mom added it to ours, to our skins. We added it to our kids. But why do we do that? What's the purpose?
Just stare it.
Doesn't it
Two
clean
reasons.
the cut?
Pardon?
It cleans it?
Yep, it brings up any microbes that might be deep in the wound and bubbles them to the surface. So there's that mechanical kind of cleansing process. Absolutely. Yep, that's one. What's the other one?
It's toxic to anaerobes. Does it say that right there?
Amazing, it does. Yeah, if you get a cut, how do you know from falling, you're out shoveling the garden, you're spading the garden, I don't know, some weird thing happens, you fall, you cut yourself, you get dirt in the cut, you're out trimming trees and you slip with a saw and it hits your arm. That happened to me actually a couple of years ago. I got pericarditis as a result, but that's another story. You can have not only aerobes introduced into that cut, but potentially anaerobes. And so as Diana mentioned, the production of oxygen is toxic to anaerobes. Yeah, so those are the two reasons why hydrogen peroxide is such a really nice thing to have in case you do get a cut. And my mom never had it in our medicine cabinet, so I don't have it here, but probably should. I do know when you get blood on your clothes, you know, one way to take it out before you launder the shirt. You all know this, don't you?
Isn't it peroxide?
Well, you can use whatever spray you got in there too. But yeah, put some hydrogen peroxide on that cut. Now that blood might have been dry for 2 or 3 days. Guess what? When you put that little drop of hydrogen peroxide on that little spot, it's going to start to bubble. You're going to see it bubble, and it'll actually just almost erase the blood right out of the fabric. It's amazing. Yeah, so. And so, yeah, it's a matter of going through these and being just a little bit familiar with different types of aldehydes. You've all heard of this. If you've ever dissected a frog in high school, right? You've heard of formaldehyde. Now, today's preserved specimens, unlike this brain, but if you go and dissect a frog or a pig or whatever in biology lab today, we're using about a 5% formalin or 5% formaldehyde solution. It's much more reduced than it was when I was taking, you know, college classes. There, I think the formaldehyde was, you know, I don't know for sure, but you know, it was 50% or higher. I know it was, because boy, you open that lid and it's like,
It stunk.
it really was nasty. And you know, I think about how many brain cells must have died over the millennia for kids who breathed that stuff in, because oh, it couldn't have been healthy. But nonetheless, it is a very effective preservative. But it can be a good disinfectant too, but you got to be kind of careful you don't. Well, you don't, if you're using it on living tissue, you really shouldn't be, because it's not designed as an antiseptic. It's more of a disinfectant, as it mentions. Yeah, I think you just need to kind of go through these 8 or so different topics, germicides, and kind of know the difference between how a soap and a detergent works versus an aldehyde, let's say. So these are focusing in on the nucleic acids. Does that sort of help? Other questions? We just recently, did a lab on UV. So you're already familiar, hopefully, with UV. That's here somewhere. Where did I see UV? Right. So I think it's a pretty good dovetailing between lecture and lab topics recently. So some of this is not totally new. Shouldn't be. I think with respect to chapter 11, that this is that overarching slide that I remember going, through with you guys when we first introduced this topic. This is just a nice flow chart, and it kind of brings back in one fell swoop the 3 major control mechanisms or agents. So you can always kind of go back to that to kind of get the big picture. And it's interesting to note that many of these do result in sterilization of the material, whether it's a inoculating loop or a medium or a surface, but others are not designed as sterilizers. They may be designed as disinfectants. As we talked about last Thursday, I think UV light doesn't have the same wavelength of penetrating power, so it's not very effective really as a sterilant. It disinfects quite well, and you watch that video, right, that talked about the UV lamp moving around the hospital room, right? That was really interesting. Or the UV lamp that was recently invented that you could wheel down the middle of the airliner, and the arms extended out, and it zapped the seats of the passengers. And now with COVID-19, gosh, I think I would like to invest in some of that technology, because I bet you they're going to be making lots of those machines. Yeah, that and oil tankers. Buy it. If you get a chance to buy an oil tanker in the next couple of days, buy it. Because they have nowhere to store the oil. You've heard about that, haven't you? The price of oil is like down to negative numbers. It's crazy. Oops. Okay, other questions? 9, 10, 11, 12. Vera, it looks like you have a question.
No, I don't.
You don't. Okay. Well, I think after this week, we only really have 2 more weeks. So getting down to the end. The college is in the process of putting together summer courses. We've already actually done that, but we're, as you may have heard, going all remote now for summer 1 and summer 2. So I don't know if any of you are thinking about taking summer classes, but there'll be something coming out very shortly about those classes. We are not going to be offering micro lab this summer. I'm supposed to teach 2 labs, and I just said, you know, we can't teach lab online. It just doesn't work. So. All right, last call. Questions, comments?
No.
Anybody? Okay. I assume you still want to meet on Thursday?
Yes.
Okay. Great. I will be here. I have not looked at the quizzes at all. I had a very crazy morning and I have a crazy afternoon, and I probably won't get to look at those until tomorrow at the earliest. So I think I posted, what did I say? You could check your results. Was it tomorrow at 9? I'm getting all my classes mixed up.
Yeah.
Okay.
Tomorrow from that.
So let me tell you how I do this. I go into the grade center, and any questions, and this is the case for lecture or lab, that require you to do any writing or even fill in the blanks, I double check those. I have to obviously read the essay and the short answer questions, but if I do a fill in the blank, let's say, and you misspell the word like bacteria and you spell it with an AI at the end, not that you guys would ever do this, I know, but let's say you do. They're gonna mark it wrong, but in the goodness of my heart, I would give it to you. So your score that you might see tomorrow, if I don't get to looking at them before then, you know, you may end up getting a point or 2 or whatever. It depends. I'm going to try to get in there and read all that, but I guess what I'm trying to say is the system will correct the multiple choice in an instant, in a millisecond, but I've got to correct all of the other stuff. So I hope to have that done by tomorrow, or let's just say maybe Thursday by 9. If I don't get to do it tomorrow, I'm going to try to, but I've got so much to do. I don't know if I'm coming or going. All right. Are you guys as busy as I am?
Yes.
Yeah, you are? Everybody's shaking their head, so. Okay, well, hang in there. You only got 2 weeks left. 3 weeks.
Gone fast.
Well, you know, it's hard to believe it's been a month we've been doing this. I think it's in some ways gone really, 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 really slow. In other ways gone really, really, really fast.
And it's hard to keep track of what day it is.
Oh, I know it. Yeah, is this Monday or Wednesday or Friday or what? I know it. Our whole lives are just turned upside down with this. Now, I'm curious, and not to get off topic, but we can talk for maybe a few minutes. I'm really curious what you guys think about states like Georgia and Florida and Texas just opening up, and the pressure that governors are getting to do that. What do you think?
It's just it's risky.
Risky.
Yeah.
I think it's pretty reckless.
Agreed.
I can see both sides of the coin for like small businesses, but I don't know.
Uh-huh.
I think like like a slow reopening. You can't just like open up everything and hope for the best. I think you just kind of have to move more slowly, I think.
Uh-huh.
But there are some areas that, I mean, you think of our small area out here, we have to abide by what the city abides by, but yet we're limited in what we can do because out in New York City, can you really be 6 feet away from everybody on the sidewalk? No. But here, you know, I'm not so sure we should have to abide so heavily by what they need to out there.
Yeah. Well, if you've been watching at all the governor's news conferences, which are typically daily, he's, I think, aware of the fact that Cattaraugus County isn't Queens or Westchester, you know, that we share different demographics, significantly different. And so one would hope that that would be taken into account. I mean, some states like Iowa, where my sister and brother live, the governor's divided the state up, I think, into 9 zones. And I'm sure that'll play into how those regulations and so forth are implemented or relaxed or what have you. So yeah, one would hope that you know, that would be taken into account. My fear, and of course the major fears of a lot of people, are that if Georgia and Florida beaches open and Texas beaches open and all that, that you're going to get potentially a big inundation of COVID patients. They're going to overwhelm the system. And oh, it's hard for me not to get frustrated from the politics, and everything, you know, seems to revolve around that whole thing, which is, I don't think you can put people's lives in danger like that. I think it's not only reckless, I think it's immoral. I think it should be illegal. But how do you, I don't know, you can make different points from different vantage points, I guess, different people, you know. Hate to see people die unnecessarily just because you want to get back to work or you want to get reelected or whatever. I don't know. I think it's just really sad. Especially if you know somebody who's died of it and how they died of it. You've all seen the stories. I mean, it's beyond tragic. Was your father, mother, grandmother? I mean, I don't think people necessarily think of that very much sometimes. Anyway, okay, well, you guys have a good rest of today and tomorrow, and I will see you Thursday at 1:15.
All right, sounds good. Thank you.
You're welcome, guys.
Thank you.
Thank you.
Thank you.
See ya.
Thank you.
See ya.
Bye.